Hello again, Econ 160, and welcome back to another video lecture. Today we're going to be taking a deeper look into how markets work, starting with the forces of supply and demand. Now, you've probably heard of the term supply and demand before, and you might even have a vague notion of what it means. And that makes sense because I think when most people think of economics, the first thing they think about is supply and demand. And that's for good reason, because supply and demand are two of the most important forces that determine the behavior of markets. But have you ever sat down and wondered to yourself, what exactly is supply and what is demand? Where do they come from? How do they interact? Well, in today's lecture, that's what we're going to be talking about. We're going to see how supply and demand arise from the choices of individual decision makers, and we're going to see exactly how the two forces interact in order to determine prices and quantities in markets. And what we learn today is going to set the stage for a wide variety of very rich analysis down the road, and it's going to become a powerful tool for economic analysis. And the person you see on the right here is the great 19th century economist Alfred Marshall. Now, Marshall didn't invent the theory of supply and demand, but he wrote one of the most influential textbooks of his time, and much of the way of how we teach economics today has been influenced by him. And so he was certainly instrumental in teaching a generation of economists how to think carefully and rigorously about supply and demand. So here are the learning outcomes for today's lecture. By mastering this lesson, you should be able to first explain the meaning of supply and demand in a competitive market, including explaining what a competitive market means. Explain what a market equilibrium is and how supply and demand interact to equilibrate a market. You should know how to read a supply and demand diagram and find the market equilibrium. And you should be able to calculate equilibrium prices and quantities using supply and demand as represented by equations. Okay, you should be able to explain how supply and demand arise from the utility maximizing decisions of buyers and sellers. And finally, you should explain why in market equilibrium, price equals the marginal benefit of the consumers, and price also equals the marginal cost of the producers, and why this implies that the total utility in the marketplace gets maximized. So I know that might sound like a bit of mumbo jumbo at this point, but hopefully it'll become clear by the end of the lecture. So before we can begin our study of supply and demand, we first have to describe the setting in which the supply and demand is taking place. And so we first have to describe the market that we're going to be thinking about. And so for the purpose of thinking about supply and demand, we're going to focus on what is called competitive marketplaces, okay? And so when an economist says a competitive market, they have something very specific in mind. They're thinking about a market where first there are many small buyers and many small sellers, okay? And what small means is that each individual buyer or seller only commands a very small market share of the total demand or total supply. And second, that all the goods traded in the marketplace are exactly identical. Okay, so there are no differences in either the nature or the quality of the goods that are being traded. And so in real life, some markets are more competitive than others. There is no universally agreed upon definition of which markets are truly quote-unquote competitive and which aren't. But we can use these definitions here to assess for any particular marketplace in real life whether we think they're likely to be more competitive or less competitive. Okay, so here are some examples. So the global market for coffee beans, that's going to be pretty competitive because there are lots of small buyers, right? Small coffee shops, grocery stores, individuals, and then there are a lot of small sellers, right? So there's a lot of small coffee farms in the world as well. And coffee beans, although coffee snobs might disagree, for the most part are pretty similar to each other, pretty interchangeable. And so the assumption of all goods traded being identical is a fairly decent assumption, okay? And for markets like corn or soybeans, it would probably be even more true for those markets, right? We can also think of markets that aren't so competitive. Let's say the market for automobiles. Okay, you might think the market for automobiles is pretty competitive, and it is, But it doesn't really fully satisfy these definitions too well because although there are lots of small buyers, the sellers themselves are not that small, right? The market for automobiles has a lot of large companies, and moreover, it doesn't really satisfy the second condition, right? Because each car is very different. Each brand of automobile has its own unique characteristics. And so we can't really say that all the goods traded in the market for automobiles are identical. And of course, we can also think of markets that are not competitive at all, like the market for internet search engines, which is really only dominated by just one seller, right? One supplier, which would be Google. And every other supplier for internet search has very minimal market share. So the model of supply and demand that we're going to be looking at today does assume that the market is competitive. And so as a tool for understanding real-world markets, the model that we're going to learn today is going to apply best to markets that satisfy the conditions of competitiveness. Of course, like I said, competitiveness is a matter of degrees, and so the lessons that we learn today are still going to be applicable to markets like automobiles, maybe just to a lesser degree, and there might be additional factors to consider when we're looking at less competitive markets. And in fact, we're going to be discussing those other factors in less competitive markets in later lectures of this course. Now, under the assumptions of a competitive market, there can only be a single price for the good, right? What that means is that all transactions are going to take place at the same price. This idea that there can only be one price for a good in a competitive market is known as the law of one price. But now let's ask ourselves why a competitive market can only sustain a single price. And here's the logic, right? Since the goods are exactly identical, if two sellers asked for different prices, no buyer is going to want to buy from the higher price seller. Everyone is going to buy from the lower price seller. And so all of the transactions are going to take place at the lowest asking price from the sellers. And if two buyers offer different prices to sellers, then no seller is going to want to sell to the lower priced buyer, right? They're all going to sell to the higher priced buyer. And what that means is that all transactions are going to take place at the highest bidding price. And bidding price is what we mean by the price that buyers are willing to pay, okay? And so because of this logic, in a competitive market with identical goods, all transactions are going to take place at the same price, and that's the law of one price. Is the law of one price realistic? An unspoken assumption that we made here is we assume what's called full information, which means that all buyers know all the sellers' asking prices and all sellers know all the buyers' bidding prices, right? In reality, this isn't usually the case, right? And so real life markets often can have transactions happening at different prices, even for exactly identical products, right? And in fact, economists have a name for this, and it's called price dispersion, okay? Price dispersion is an interesting phenomenon that we're not going to cover in this course, but in more advanced studies, you might encounter models that give rise to price dispersion. But for now, I definitely think the basic model of supply and demand is good enough, right, to describe the primary forces which are driving the market. Because remember, the purpose of an economic model isn't to capture 100% of reality, but rather to highlight and understand the principal economic forces driving the market, right? And the basic forces of supply and demand are usually going to outweigh the effects of price dispersion. And so we're going to start with the simple assumption that the law of one price holds. And we're just going to acknowledge that it's not a perfect, but still very useful description of reality. Okay, one last thing to talk about the setting before we actually get into supply and demand. And this is that when the buyers are small and the sellers are small, and when the law of one price holds, then we can say that buyers and sellers are what's called price takers, okay? And the definition of a price taker is that a price taker is someone who has no individual influence over the market price, okay? So they can't really influence the market price either up or down. And because of that, they just make decisions taking the market price as given. And I think that's easy for us to understand, right? Because in real life, most of us are price takers in the markets in which we participate. So think about the market for coffee, right? Your individual buying habits for coffee are not going to have an effect on the price of coffee, right? Even if you doubled or even tripled your daily coffee consumption, it's not really going to change the price of a cup of coffee or a bag of beans. And similarly, a small coffee farmer's production is also not going to have an effect on the price of coffee. Whether they, for a small farmer, whether they double, triple, or halve their production for a year, that's not really going to affect the global price of coffee in the marketplace, right? So I think it's easy to understand what it's like to be a price taker. Now, the consequence of being a price taker is that when buyers are price takers, their main decision is simply just to look at the price. They're going to look at prices, say on a menu, and they're going to decide whether and how much they want to consume. So their choice is mainly a quantity-based choice, right? They're choosing how much to consume, taking the price as given. And similarly for sellers or producers, right? When sellers or producers are price takers, their decision is simply to look at the price and decide how much they want to produce and sell. So their decision is also a quantity-based decision of how much to produce and sell. All right, so let's start talking about supply and demand, finally. And we're going to start by talking about demand, all right? And we're going to start by talking about what's called an individual demand schedule, okay? So for an individual buyer, their demand schedule is a table that shows how much that this buyer is going to buy, given the market price, assuming nothing else but the price is changing, right? So it's a table that's going to list a bunch of different prices, and for each price, it's going to show how much the person is going to want to buy. And so this is the demand schedule for a hypothetical person named Annie. And this demand schedule says that when the price of a cup of coffee is $3.50, that Annie is going to buy 0 cups of coffee. When the price is $3, Annie's going to buy 1 cup of coffee. When the price is $2.50, Annie's going to buy 2. When the price is $2, she's going to buy 3. When the price is $1.50, she's going to buy 4. And when the price is $1, she's going to buy 5. Okay? Very simple. This is what a demand schedule is. Now, a demand schedule can also be represented visually by something known as a demand curve, all right? So a demand curve is simply the graphical representation of a demand schedule. And how we're going to do that is we're going to put price on the y-axis, okay? So that's the convention in economics, to put price on the y-axis. And we're going to put quantity on the x-axis, okay? And the demand curve is just going to trace out the information in the demand schedule onto this axis, okay? So let's do that, right? So at a price of $3.50, Annie's going to demand 0 quantity. So at a price of $3.50 here, Annie's going to demand 0 coffee. And so this is the point on the graph representing the demand at $350, okay? At a price of $3, Annie's going to demand 1, and so that's over here. All right, at a price of $2.50, she's going to demand 2. At a price of $2, she's going to demand 3. At a price of $1.50, she's going to demand 4. And at a price of $1, she's going to demand 5, right? And so we can connect the dots, and there's Annie's demand curve, all right? So a demand curve is simply the graphical representation of someone's demand schedule. So just as an individual buyer can have a demand schedule, the market as a whole can have a demand schedule as well, right? And so the market demand schedule is just going to show how much consumers in the market as a whole are going to want to buy in total at each price level. Again, assuming nothing else but the price is changing, all right? And so here now, we have the market for coffee, and this time instead of just Annie, we also have Bart and we have Chloe, and let's just assume that those are the only 3 buyers in the market. And here we have Annie's individual demand schedule, here we have Bart's individual demand schedule, and here we have Chloe's individual demand schedule. And we can actually construct the market demand schedule from the buyer's individual demand schedules, right? And the way we do that is we simply add up the demand from each individual buyer at each price level, right? So let's do that. At a price of $4, Annie demands 0, Bart demands 0, Chloe demands 0, and so the total market demand is 0, right? At a price of $3.50, Annie still demands 0, Bart now demands 1. Chloe still demands 0, and so the total demand is 1. Okay? At a price of $3, Annie demands 1, Bart demands 1, Chloe demands 0, and so the total is 2. At $2.50, Annie demands 2, Bart demands 1, Chloe still demands 0, so the total is 3. At $2, Annie demands 3, Bart demands 1, Chloe demands 1, so the total is 5. Okay, and so you get the picture. We can just continue on, just adding up each of the buyer's individual demands in order to get the market demand schedule. And so the market demand curve is just going to be a graphical representation of the market demand schedule. Here's the market demand schedule that we just constructed from the last slide. And let's plot this onto the graph to make the market demand curve. So at a price of $4, the market demand is 0. So $4 is here with 0 quantity, so that's right here. At a price of $3.50, demand is 1, and so that's right here. At a price of $3, the market demand is 2, and so that's right here. At a price of $2.50, the market demand is 3, so that is right here. At a price of $2, the market demand is 5, so that is right here. At a price of $1.50, the demand is 8, and that's right here. And at a price of $1, the demand is 11, and so that is right here. And so if we connect the dots again, all right, we get the market demand curve. All right, so this is the market demand curve based on the individual demands that we saw in the previous slide. So one thing that you might have noticed is that the demand curves were sloping downwards, right? Which means that as the price increases, the quantity demanded decreases, or to put it another way, as the price decreases, the quantity demanded increases. Right, and this makes a lot of sense because when prices go up, and assuming nothing else is changing, then people naturally are going to want less of the good, right? Now this requirement that nothing but price is changing is known in Latin as Ceteris Paribus, which is just a fancy way of saying other things equal, okay? Right, Ceteris, if you've ever heard et cetera, ceteris just means like things or other things. And paribus, if you've heard the word parallel, means similar or same, okay? And Ceteris Paribus is an important concept because it allows us, when we're talking about demand curves and supply curves, to focus only on the relationship between price and quantity, right? Leaving out the effect of other things, right? And so what are some of the other things that we might worry about? And why is it important that we focus only on the relation between price and quantity when other things are held constant? And so let me just give you an example, right? So from 2001 to 2008, you might have heard about the Great Recession, but before that there was a big run-up in housing. And so between 2001 to 2008, house prices and the number of homes sold both went up at the same time, right? So quantity and price both went up at the same time. And so does this mean that buyers' demand curves were actually upward sloping, that as prices go up, buyers actually want more of something? Well, not really, because what was happening is that other things, right, besides just price were changing at the same time, right? Incomes were going up and mortgage rates were going down, okay? And so those things were actually pushing up price and quantity at the same time. And so it's important to remember that when we're talking about demand curves, the demand curve is really holding those other things constant, and it's just showing when price but nothing else changes. If the other things are changing, what actually happens is that the entire demand curve is going to shift, and we're going to talk about that in the next lecture. Okay, so that was demand. Now let's talk about supply. And we're going to start by talking about a supplier's individual supply schedule, right? So a seller's individual supply schedule is a table showing how much that seller is going to choose to sell or produce given the market price. And again, Ceteris Paribus, assuming nothing else but the price is changing. So here's the supply schedule for a hypothetical seller in the market for coffee, Star Beans. If the price of a cup of coffee is $4, Star Beans is going to want to produce and sell 6 cups of coffee. If the price is $3.50, Star Beans is going to want to produce and sell 5. If the price is $3, Star Beans is going to want to sell 4. If the price is $2.50, Star Beans is going to want to sell 3, okay, and so on. So this is a supply schedule for Star Beans. And now let's translate Star Beans' supply schedule to a supply curve. Again, we're going to put price on the y-axis and quantity on the x-axis. And this time, let's actually start from the bottom. So at a price of $1, Star Beans is going to want to sell 0, so that's right here. At a price of $1.50, Star Beans is going to want to sell 1, so that's right here. At a price of $2, Star Beans is going to want to sell 2, that's right here. At a price of $2.50, Star Beans is going to want to sell 3, and so that's right here. Okay, and so on. $3, 4, $3.50, 5, and $4, 6. Okay, and so we connect the dots, and this is Star Beans' individual supply curve. So that was the supply schedule and supply curve for an individual seller, Star Beans. And now let's talk about the market supply schedule. So the market supply schedule is a table that's going to show how much the suppliers and producers in the marketplace are going to want to sell and produce in total at any given price level, again, assuming that nothing else but the price is changing. Okay, so here's an example. Suppose in the market we have 3 sellers. We have Star Beans, which we already saw, and here's Star Beans' individual supply schedule. We also have Pete's, and here's Pete's supply schedule. And we also have Slurptown, and here's Slurptown's supply schedule. So to calculate the market supply schedule, we're just going to be adding up each individual supplier's quantities at each price, right? So at a price of $4, Star Beans is going to supply 6, Pete's is going to supply 2, Slurptown is going to supply 2, and so the total market supply is going to be 10. At a price of $3.50, Star Beans is going to supply 5, Pete's is going to supply 2, Slurptown is going to supply 2, so the total market supply is 9. At a price of $3, Star Beans supplies 4, Pete's supplies 2, Slurptown supplies 2, so the total is 8. All right, and so we can continue on adding up the quantities for the individual sellers, and we're going to complete the market supply schedule, okay? So now let's translate that to the market supply curve. Here's the market supply schedule that we just calculated, and we're just going to translate that into the graph here, okay? Again, let's start at the bottom. At a price of $1, the market supply is going to be 0, so that's right here. At a price of $1.50, the market supply is going to be 3, and so that's right here. At a price of 2, the market supply is going to be 5, and so that is right here. At a price of $2.50, the market supply is going to be 7, and so that is right here. Okay, at $3, it's going to be 8. At $3.50, it's going to be 9. And at $4, it's going to be 10. All right, and so if we connect the dots, here we go. Here's the market supply curve. All right. One thing to notice is that the market supply curve and supply curves in general are going to be upward sloping, which means that as you increase the price, the quantity that suppliers are going to want to sell is going to increase. And that makes sense because when price goes up, naturally sellers are going to want to sell more of the product. Okay, so now that we know what supply and demand curves are, let's see how supply and demand work together to generate outcomes in the market. And to do that, we're going to put supply and demand curves on the same graph. So we can start by putting the market supply and market demand schedules on the same table, and so that's right here. And we can use the data here to plot supply and demand curves on the same graphs, okay? So I'm not going to go through how to do it because it's really the same as what we've already done. But if you went ahead and plotted these on the graph, this is what you're going to get, right? So this is our demand curve in our hypothetical market for coffee, and this is our supply curve in the hypothetical market for coffee. And we're going to use this joint supply and demand diagram to ask questions about what happens in the market. So first, let's ask what happens in the market if the price is $1.50. To investigate this question, we're going to start by drawing a line here at 150 to indicate the price. And so the purpose of that line is just to focus our attention on the price being at 150 for now, okay? And we're going to ask what's the quantity demanded here when the price is 150. To do that, let's look at the demand curve when the price is 150, and that's right here. And so the quantity demanded is 8, right? So when the price is 150, the quantity demanded is 8. Then let's ask what's the quantity that's supplied. To figure that out, let's look at the supply curve. Let's look at what the supply curve says at $1.50. That's right here. And so the quantity supplied when the price is 150 is 3, right? So the quantity supplied is 3. But what does that mean? That means the quantity demanded is higher than the quantity supplied, right? The quantity demanded is 8 and the quantity supplied is 3. And so the difference is this distance here, right? The distance between the demand and the supply curve when the price is 150, and that's how much excess demand you have, right? And how much excess demand is there? Well, demand is 8 and supply is 3, and so the excess demand is 5 cups of coffee, right? And so what do you think is going to happen when there's an excess demand of 5 cups of coffee? What that means is some buyers who want coffee can't get it, right? So you might have a situation where people actually have to start to line up for coffee, and then they don't get the coffee unless they are lucky enough to show up to the line first. What's going to happen when there is this shortage of coffee, right? The prices are going to be bid up over time because buyers are going to realize that for them, in order to guarantee that they get a cup of coffee, they might have to offer a higher price than what the current market price is. And sellers, seeing the excess demand, are going to realize that they're going to be able to raise prices over time without losing sales, right? And so what's going to happen when there's a shortage is that the prices are going to be bid up over time. So now let's ask what happens if the price is 250 instead of 150, which we just looked at. And so to investigate this question, again, we're going to just start by drawing a line here at the price of 250 to focus our attention on that price. What's the quantity demanded when the price is 250? We look at the demand curve, right? Demand curve is here, and so the quantity demanded when the price is 250 is right here, it's 3. So quantity demanded is 3. What's the quantity supplied when the price is 250? Let's look at the supply curve. All right, here's where the supply curve is at 250. And so the quantity supplied is 7. Okay, what does that mean? That means there's more supply than demand, right? And so we have excess supply, and the excess supply is this distance here between the supply and the demand curve. Okay, and the excess supply, since there's 7 supply and 3 demand, the excess supply is 4 cups of coffee, right? And excess supply, we sometimes also use the word surplus to describe that. Now, what happens to the market when there's an excess supply? What happens is that sellers are going to have product sitting on shelves that they can't get rid of, right? So in the context of coffee, they might have these beans sitting on the shelves that aren't getting used and they're not turning into cups of coffee, right? And what's going to happen is that sellers are going to realize that in order to actually move that product, they're going to have to lower their prices. So what happens when there's excess supply is that sellers are going to lower prices over time so that they can get rid of the excess supply, right? And so prices are going to go down over time when you have excess supply. So if prices are too high and there's excess supply, prices are going to go down over time. And if prices are too low and there's excess demand, prices are going to go up over time. Is there any point at which we can say the market stabilizes and price is not going to change? Well, there is, okay, and that's what we call a market equilibrium. So an equilibrium happens when the price is just right, meaning there's no excess supply or excess demand. And when that happens, the price is not going to change, right? So the word equilibrium means a state of balance in which things do not change. And so the market equilibrium is where there's no excess supply and no excess demand, and prices remain stable. And so where's the market equilibrium for our market over here? Well, the price at which supply equals demand is at $2, right? And so we call that the equilibrium price. And the market equilibrium itself, we say, is that point of intersection between the demand curve and the supply curve. And then the quantity which is going to be traded in equilibrium is right here, 5, and we call that the equilibrium quantity. Okay? So to recap, a market equilibrium is when the quantity supplied equals the quantity demanded, and the price at which that happens we call the equilibrium price, and the quantity that gets traded at that equilibrium price we call the equilibrium quantity. So why is the concept of a market equilibrium important? Well, it's important because economists believe that competitive markets can't be out of equilibrium for very long. Right, so if anything happens to push a market out of its equilibrium, we tend to think that it's going to re-equilibrate fairly quickly. Right, so if anything happens to create excess demand, then prices are going to be quickly bid back up to the equilibrium price. And if anything happens to create excess supply, then prices will quickly be bid down to the equilibrium price. Okay, and so because of this, because economists think that markets most of the time are going to be in equilibrium or close to equilibrium, we use the concept of a market equilibrium to predict what happens to prices and quantities in markets. Okay? Now, of course, the reality is a little more complicated, right? Because the exact speed at which a market equilibrates might depend on the features of the market, or it could depend on the market conditions at the time. And of course, those other things could be changing simultaneously. And so it's very difficult for us to assess at any point in time whether a real-world market is truly, quote-unquote, in equilibrium or not. But despite this, our historical and empirical observations do confirm that prices do seem to respond to the market forces of supply and demand in the ways that would be predicted by market equilibrium, right? So the usefulness of the supply and demand model to predict prices and quantities in markets has proven itself over time, and so its basic usefulness is not in doubt, and we're going to be making use of it a lot. Just keeping in mind that, of course, reality always has a lot of more wrinkles and complications than our simple model can address fully. All right, so far we've been representing supply and demand using either tables in supply schedules or using graphs in supply and demand curves. But another way to represent supply and demand is with equations, all right? And we're not going to work with equations too much in this class, but what you'll find out is if you ever move on to more advanced studies, that as models become more and more complicated, it becomes more and more difficult to represent things graphically, and equations then become much more convenient. So I do think it's important to at least have some basic familiarity with how we work with equations in economics. And so let's work on an example, all right? So here I'm giving you a demand equation, right? This says that the quantity demanded is a function of price P, and quantity demanded is equal to 10 minus P, right? So what that means is that if price is $1, then 10 minus 1 is 9, and so quantity demanded is 9, right? If price is $2, then quantity demanded is 10 minus 2, which is 8. So that's what this equation is saying. And then we also have the supply represented as an equation. So the quantity supplied is equal to 2 plus P. And what that says is that if price is 1, then quantity supplied is 3. If price is 2, then quantity supplied is 4, right? And so on. So that's what this equation says. And so we're going to find the equilibrium price and quantity in the market. One thing you could do is you could put it on a graph and then solve for it visually. But we're actually just going to work with the equations. And so remember, equilibrium means quantity supplied equals quantity demanded, right? So the first thing we're going to do is we're going to find the price that makes QS equal QD, right? And that would be the equilibrium price. So we start by writing down QS equals QD. Then we plug in the equation for QS and we plug in the equation for QD, right? And so we get 2 plus P equals 10 minus P, right? And so we're going to solve this for P in order to find the equilibrium price. So to do that, the first thing we do is subtract 2 on both sides to move the numbers all to one side. And so we get P equals 8 minus P. Then we're going to add P to both sides, right, to put all the P's on one side. So we get 2P equals 8. And finally, we divide both sides by 2, and we get P equals 4, right? So this is our equilibrium price, P equals 4. Now to get the equilibrium quantity, we simply plug this price into either the supply equation or the demand equation, and we're going to get quantity. And in fact, you could choose either one. Both of them should give you the same answer. If you don't get the same answer from both of them, then you actually probably got the wrong equilibrium price, right? Because the equilibrium price is where these two equations should be equal. So let's go ahead and plug it into QS. So QS is equal to 2 plus P. We found that P equals 4, so QS is equal to 2 plus 4, which means the equilibrium quantity is equal to 6, okay? So our equilibrium price is 4, and our equilibrium quantity is 6. And so that's how we would use equations to find market equilibrium. Okay, so we're going to finish off the lecture by talking about where supply and demand curves come from. Because so far, all I've told you is what they are, but I haven't told you anything about where they come from, right? And if you thought to yourself, based on our discussion in the second lecture on decision theory, that it has to come from some kind of decision making by the buyers and sellers, you'd be correct, right? Demand curves come from the utility maximizing decisions of buyers. So how does that work? First thing to remember, when deciding how much of something to buy, a buyer is going to choose up to the quantity where marginal benefit equals marginal cost, right? That was our principle of utility maximization. That utility is maximized when marginal benefit equals marginal cost. Now for a price-taking buyer, right, their marginal cost, the additional cost that they incur for each unit that they purchase, is simply equal to the market price, right? Because if you're a price-taking buyer, the amount that you have to pay for every unit purchased is just the price, and so your marginal cost is equal to the price, right? All right, so how does that translate into a demand schedule? Let's work on an example. Here I have a table that shows the marginal benefits for a hypothetical person. And so what this table says is that as the person goes from buying 0 to buying 1 unit, the additional benefit of the first unit is $5. As he goes from buying 1 to 2 units, the marginal benefit of that second unit is $4. As he goes from 2 to 3 units, his marginal benefit of the third unit is $3, and so on. Okay, so the marginal benefit of the fourth unit is $2, and the marginal benefit of the fifth unit is $1. Okay? And so using the principle that they're going to choose up to the quantity where marginal benefit equals marginal cost, we're going to be able to use that to construct this person's demand schedule. Okay, so how do we do that? First, let's consider, what if the price is $5? If the price is $5, then the marginal cost for this buyer is $5, right? And they're going to buy up to the quantity where marginal benefit equals marginal cost. So they're going to buy up to the quantity where marginal benefit equals 5, right? And so that's at 1 quantity, right? Marginal benefit is 5. So when the price is $5, the amount that this person is going to buy is 1, right? So now what about $4? When price is $4, the marginal cost to this person is 4, and so he's going to buy up to the point where marginal benefit equals 4, and that happens at a quantity of 2. And so when the price is 4, he's going to buy 2 units, right? And when the price is $3, the marginal cost is 3, so he's going to buy up to the point where marginal benefit is also 3, and that happens at 3 quantity. And so at a price of 3, he's going to buy 3 units, right? And so using the same logic, we can fill out the rest of the table. At a price of $2, he's going to buy 4, and at a price of $1, he's going to buy 5. Okay? And so if you look at these two tables, the relationship between quantity and marginal benefit is equal to the relationship between quantity and price. Okay? And so what we can conclude is that a person's demand schedule is actually going to be exactly the same as their marginal benefit schedule. And if you were to put marginal benefits on a graph and the demand curve on a graph, what you would notice is that the marginal benefits curve is going to look exactly the same as the demand curve, all right? with the only difference being that the y-axis here is measuring marginal benefit and the demand curve here is measuring price, right? But otherwise they're going to be exactly the same, okay? And so we can say that the demand curve is equal to the marginal benefit curve of the consumers in the market. So where do supply curves come from? You guessed it, supply curves come from the utility maximizing decisions of the suppliers, right? And just like with buyers, right, when deciding how much of something to supply or produce, a supplier is going to choose up to the quantity where their marginal benefit equals marginal cost, right? Same thing. But there is a difference, and it's that for a price-taking supplier, their marginal benefit is what's going to be equal to the market price, right? Not the marginal cost, right? The marginal benefit, the additional benefit they get from each unit sold is going to equal to the price because the payment that they receive for each unit sold is simply equal to the price, right? So for suppliers, their marginal benefit, not their marginal cost, is equal to the price. And so how does that translate to a supply curve? Well, let's do an example. Right here is the marginal cost curve of a hypothetical supplier or producer. We use those terms interchangeably. And so what this marginal cost schedule says is that for the first unit produced, the marginal cost is $1. For the second unit produced, the marginal cost is $2. For the third unit produced, the marginal cost is $3, and so on. Okay, and we're going to be able to use this information to fill out a supply schedule for this seller. If the price is $1, what does that mean? It means their marginal benefit is $1, right? And so they're going to produce up to the point where their marginal cost is $1, and that happens at a quantity of 1. So the quantity supplied at $1 is just 1. At a price of $2, their marginal benefit is $2. They're going to produce up to the point where their marginal cost is $2, and that happens here at a quantity of 2. So their quantity supplied will be 2. At a price of $3, their marginal benefit is 3. They're going to produce up to where their marginal cost is also 3. That happens at a quantity of 3. And so at a price of $3, quantity supplied is 3. Okay? And so on. And we can fill out the rest of the table using that logic. All right? And so if we were to plot the marginal cost curve and the supply curve on graphs, we would see that they look exactly the same, right? With the only difference being that here the y-axis is measuring marginal cost, and here the y-axis is measuring price, okay? But otherwise, the marginal cost curve and the supply curve are the same. And so we can say that the market supply curve is equal to the marginal cost curve of the producers or the suppliers in the market. All right, so this interpretation of the market demand curve as being equal to the consumer's marginal benefits curve and that the market supply curve is equal to the producer's marginal cost curve has some really important implications. First, it says that in the market equilibrium, that the equilibrium price is going to be equal to the marginal benefits of the consumers. And so that what that means is that if we look at the price in a market, we can learn something about consumers' marginal benefits, right? The price is going to tell us how much does the marginal consumer value the good that he's buying in the market. Second, it says that in the market equilibrium, the equilibrium price will equal the marginal cost of the producers. And so we can learn something about producers' marginal costs by looking at the price. The price in the market is going to equal the marginal cost of the marginal producer. And third, it says that in market equilibrium, the marginal benefit of the consumer equals the marginal cost of the producers, right? And what's maximized when marginal benefit equals marginal cost? That's right, utility is maximized, right? And so this implies that the total utility of the market as a whole is actually maximized in the market equilibrium, right? And that's kind of an amazing conclusion because the individual decisions of the buyers and sellers are simply to maximize their own utility, but somehow the utility of the market as a whole gets maximized. And we're actually going to explore this in a lot more detail in just a couple of lectures. But let me illustrate these ideas with the graph so that you can remember it better. And this is the graph that's going to put everything together, all right? So we have the demand curve over here, which also happens to be equal to the marginal benefits curve of the consumers. And we have the supply curve over here, which also happens to be equal to the marginal cost curve of the producers. The equilibrium happens where supply and demand intersect right here. And here's the equilibrium price. And so at this price, both marginal benefit and marginal cost are equal to each other, and they're both equal to the price. And since from a societal point of view, the ultimate receivers of benefit from the market are the consumers, and the ones who incur the costs in order to bring the product to market are the producers, we have that the marginal benefits to society equals the marginal cost to society, and so the total utility in the society of this marketplace is going to be maximized. So this is really quite a startling conclusion, because what it means is that consumers and producers, simply acting on their own without any outside guidance and simply making decisions according to their own interests, are going to lead to market outcomes where the total utility in the marketplace gets maximized, right? And the only real signal, you could say, to coordinate people's actions is literally just the price, right? Because people are making decisions looking at the price only. And so this is what Adam Smith meant when he coined the term invisible hand in his famous book, The Wealth of Nations, right? So Adam Smith wrote, "By directing his industry in such a manner as its produce may be of greatest value, man intends only his own gain, and he is in this, as in many other cases, led by an invisible hand to promote an end which was no part his intention." And so what Adam Smith was really saying here is that people acting in a decentralized manner, each acting according to their own best interests, nevertheless lead to promote a common good that no one intended as the original purpose, right? And so that's kind of the beauty and the amazing thing about competitive markets, is that people simply seeking to maximize their own utility nonetheless end up maximizing the utility in the marketplace as a whole, right? And so this is why economists think that competitive markets are, generally speaking, a good way to allocate resources. Of course, there are certain assumptions which are tied to the definition of a competitive marketplace. And so in later lectures in this course, we're going to be exploring what happens when some of those assumptions break down. And then we can ask whether a free market is still really the best way to allocate resources or not. Okay, so that's it for today's lecture. Here's a quick review. A competitive market is a market where there are many small buyers and many small sellers, and all the goods traded are exactly identical. In a competitive market, all goods are going to be traded at the same price, and buyers and sellers are going to act like price takers. All right, a demand curve shows how much buyers would want to buy at any given price while holding other things equal. And a supply curve shows how much sellers would want to sell at any given price, also holding other things equal. A market is in equilibrium if the quantity supplied equals the quantity demanded, and this happens when the supply and the demand curves intersect. If the price is above the equilibrium price, then there's going to be excess supply, which we sometimes also call a surplus. And if the price is below the equilibrium price, then there's going to be excess demand, which we call a shortage. All right. Demand and supply curves come from the utility maximizing decisions of buyers and sellers. And in the market equilibrium, price is going to equal the marginal cost of producers and also equal the marginal benefit of consumers. And total utility in the marketplace is going to be maximized. All right. Next lecture, we'll be talking about what happens when supply and demand changes and how we can use supply and demand to predict the effects of events which impact the market. Thank you for sticking around to the end, and I'll see you guys next time.